Thank you, Chairman, for the brief introduction. A very good afternoon to everyone. I am so honored to be here today to share with all of you a brief about the background and updates on Foc TR4 prevalence, containment measures and research initiatives in Malaysia. I'm going to start with a bit introduction on our banana industry. Banana is ranked in the top 3 of the most important food crops in Malaysia in terms of its production and export value. For the local consumption, we have dessert and cooking bananas, and the most popular variety for dessert bananas are Astali banana, Lemak Manis, Embun, and for the cooking bananas, we have Raja, Abu, Tando, Awak, Nangka, and for the export, we have Cavendish types, Berangan, and Mas. As we can see, the recent banana production is decreasing in terms of its production for local consumption and export, as well as in the planted area and the harvested area for the past more than 5 years now. It is due to the main constraint of the wilt diseases caused by the Foc TR4, as well as the Moko and black disease bacteria, Ralstonia species. A brief background on the symptoms and epidemiology of the TR4 in Malaysia that I suppose is most likely similar to all other countries. Fusarium Wilt is the most devastated disease in Malaysia and also worldwide. Currently, there are at least 24 VCGs identified in Foc, and 21 of them are present across Asia and Australia. Most edible banana cultivars in Malaysia were reported to be susceptible to Fusarium Wilt, which has caused major losses in banana plantations. Foc TR4 specifically affects Musa acuminata, Musa balbisiana, Musa schizocarpa, and Musa textilis. The inoculum of Foc in soil penetrate the roots, followed by the hyphal invasion, as well as colonizing the vascular bundles in the culms, interferes with the water and nutrient uptake to the pseudosperm and leaves. The fungus is commonly spread in infested suckers and rhizomes, as well as soil, water, and farm machinery. It is able to survive without its host for up to 30 years. The figures show the disease symptoms caused by Foc TR4 in Malaysia, including A, the wilting and yellowing of the leaves, B, the root necrosis, C, the vessel discoloration, and culm discoloration. The status of Fusarium Wilt of banana in Malaysia, the first outbreak of Foc R1 in Panama and Costa Rica in 1890, and then spread rapidly to Latin American countries. The Foc R1 resistant Cavendish cultivar was soon planted, but Foc TR4 soon emerged, causing massive destruction in the subtropics and tropics. The Foc TR4 is most virulent strain reported to date since Malaysia started to cultivate Cavendish in 1980s, but in 1990s, it already wiped out 1,000 hectares of Cavendish plantation in Malaysia. More than 50% of bananas planted in Malaysia are the highly susceptible Berangan and Cavendish, which are largely exported to Indonesia, Thailand, Singapore, and Brunei. And 70% incidence was reported in Peninsular Malaysia in 2016. Foc TR4 also attacks other popular varieties grown locally for raw consumption, such as Mas, Rastali, and the plantain used for cooking and processing, such as Awak, Abu, and Raja. And the losses due to Foc TR4 were estimated to be US dollars 14.1 million in Malaysia. According to the report published by the Malaysian Department of Agriculture, among 16 most popular banana cultivars planted in Malaysia, there are 4 most susceptible cultivars. They are Pisang Rastali, Pisang Berangan, Pisang Mas, and Cavendish. And 3 cultivars were found to be free from Foc TR4, which they are Pisang Awak, Abu, Pisang Masak Hijau, and Pisang Abu. Malaysian Department of Agriculture, DOA, has strongly recommended or encouraged all the banana growers to implement the GAP, Good Agriculture Practice Scheme, to be implemented in their farms. It is consisted of the use of disease-free planting materials derived from tissue cultured banana seedlings, as well as providing the good water drainage system, and then to manage the infected plants, by burning and burying the infected plants, disinfecting the farming tools, and also providing the training courses, disease diagnostic services, and all the information pamphlets are given to all the farmers to identify, monitor, and manage the FOC infected plants. For the monitoring and surveillance, they are regular surveillance carried out by DOA and extension officers in banana farms registered under TKPM, the Permanent Food Production Parks and Orchards Groups. It is a scheme by DOA. And then for the enforcement of biosecurity, it is through the Plant Quarantine Act 1976, which all the imported planting materials are quarantined and only issues the phytosanitary certificates once all the materials are disease-free. And then all the infected fields are quarantined to restrict the movement of disease through humans, tools, and planting materials. A growing number of research initiative has been done as our efforts to help mitigate the FOC infestation in Malaysia that covers 4 main areas. They are the breeding for resistant varieties and molecular approach for in-depth understanding of plant pathogen interaction, cultural practices, just more like the farm management, and mostly we have done a lot of research in biocontrol. Previous studies reported that Malaysia has successfully produced FOC TR4 resistant mutant, which is the Rastali mutiara, AAB, through continuous selection in infected field. So for the past 3 years, Pauzia et al. Has reported on the mutation breeding done by Mardi researchers on the development of banana, Cavendish, pisang berangan with resistance to Fusarium through chronic radiation. So the gamma irradiated plant, seedlings and mutant were screened for their resistance towards FOC TR4 in the nursery and as well in the field, the hotspot field. Recently this year, Suhaina Ahmad and a researcher from Mardi and her team from University Putra Malaysia have characterized the secreted in xylem affected genes, which is they are 6.1 and 6.8 affected genes in FOC TR4 that were found to contribute to virulence towards berangan banana. This is also useful for the early detection of FOC as a way of controlling the disease in the future. Next one is the intercropping study using 3 allium species, which is the allium tuberosum, the garlic kite or kuchai, the allium ampulopressum, porum, Chinese leek, and allium sepa agritatum, the red Indian shallot. The study showed a promising result in pot trial and also suggested to be planted as a land remedy because it is reported that the release of antifungal volatile was said to be contributed to the disease suppression in the field. Yazid et al. Have gathered information on all the biological control agents that have been tested, their effectiveness against FOC in Malaysia. There are 12 of promising DCAs have been reported, including streptomyces. Like we have 3 streptomyces here that produce inhibitory compound and could be applied through soil treatments. We also tested the non-pathogenic Fusarium oxysporum, Bucaldorea, Pseudomonas species that act as endophytes that induce host defense enzymes and systemic response in banana plants. We also have tested the Serratia maricicin, Streptomyces griseus, and Bacillus subtilis to be applied as a soil treatment. And you also have Pseudomonas aeruginosa, Pseudomonas fluorescens, and Trichoderma hazianum that produce inhibitory compounds as well. The next study is done by the Clement Wong in 2019. This study was aimed to investigate the effect of the Pseudomonas aeruginosa DRB1 and Trichoderma hazianum CBF2 against FOC TR4. 5 types of formulation have been tested, and the pesta granule formulation was the best potential carrier with a reduction of 67% of disease severity that is found to be perform better than the commercial fungicide. Mardi has also carried out a study involving the microencapsulation of Streptomyces species for the preparation of a slow-release biofungicide to control TR4. The study showed promising result up to 95% disease reduction in vitro and 100% survival in vivo. Early hotspot field evaluation also have been conducted with a high survival rate, which is 96.3%. Salahuddin et al. Has reported that lixiviate from banana pseudostem and leaf decomposition could inhibit the FOC growth and reduce up to 75% disease severity in the nursery. And chemical compounds that contributed to the antifungal activity were also determined. Next, we have the ISR, the induced systemic resistance. Sorry. The ISR approach against Fusarium Wilt. Actually, we have successfully established the ISR against blood disease bacterium, the Ralstonia caesargii, that cause the bacterial wilt disease. So we have established that. So in this ongoing study, we are trying to isolate and screen the PGPR, the plant growth promoting rhizobacterium isolates that has the ISR properties to be tested in the seedlings and in the hotspot field and also in the glasshouse. We also would like to highlight on the challenges that we are facing right now. The first one is that the new banana varieties that we think need to be discovered that could facilitate the banana breeding towards improving our local banana diversity. And for that, we could establish more international collaborative works to screen for potential Foc TR4 resistant cultivars for future breeding programs. And the second one, the effectiveness of the biological control approaches need to be proven on the larger scale, so that we need to do more upscaling field trials to evaluate the disease controlling efficacy in the long run. Malaysia also would like to engage more research work related to the Foc TR4 management strategies, such as the genomic breeding and genome editing to improve agronomic traits, including disease resistance by employing molecular markers, the metagenomic study to enable the understanding of microbial changes that lead to disease suppression, the integrated management, as well as to increase awareness and knowledge to upgrade the conventional farm management, and to track, to pay a good attention to the emergence of a new unknown FOC VCGs to prevent the spread of more virulent strains in the future. So I've come to the end of my presentation. I would like to thank Malaysian Ministry of Agriculture and Food Industries, Department of Agriculture, Plant Biosecurity Division, University Putra Malaysia, and my institute, Mardi, for the support and contribution in preparing the report. And last but not least, to all the organizing committee, TFNet, for this opportunity to present our country report. Thank you. Terima kasih.
Thank you very much, Dr. Farah. It's another interesting presentation. I think you said it right, that one of the challenges is getting to collaborate with other agencies, or international or national. I think that's what this workshop is about. Hopefully, by the end of this workshop, you will have an indication of what areas we can go forward with. I think we'll reserve the question.